Okay, so we were talking about how Bohr knew that there were energy levels in the atom, and the next thing we need to look at is actually how you draw Bohr models. So the first thing we need to look at, of course, is the periodic table, because the Bohr model deals with how many electrons there are in an atom, and the periodic table is the thing that will tell you how many electrons you have in each atom. So if you look at the periodic table, you know a little bit about it. We've looked at this before, but you've got each square that has these numbers in them. The number on this particular table in the upper left is your atomic number, which is your number of protons, but just so happens it's also your number of electrons, because protons and electrons are equal when the atoms are neutral, which for right now we're going to assume that they generally are. Also, you've got the atomic mass. Not every Bohr model includes that, but we're going to go ahead and use the atomic mass also in our Bohr models. So the other thing that you need to know is how many electrons can go in each level, because there are rules for this. And you may have seen this before, you may have heard this before, but let's take a look. So for Bohr models, and if you want to take notes, not a bad idea, but of course you can always come back to the video. So for Bohr models, again, there's a limit to how many electrons. So in level 1 of a Bohr model, you can have 2 electrons, and this little E minus symbol there, it stands for electrons. In level 2, you can have 8 electrons total. In level 3, you can have 18. And in level 4, you can have 32 total electrons. And it would go on from there. Level 4 is about as far as we'll go, simply because that's all of the levels that you need to use for the elements that we have on the periodic table. We'll talk more about that when we get to electron configurations. Now, you may look at this and think, good grief, I have to memorize all these numbers and know what goes where. The good news is that you don't, if you know how to use the periodic table. So this is where there's sort of some magic that happens with the periodic table. So if you look at your numbers here, for the first level of the atom, I can have 2 electrons. And I want you to look at the first level of the periodic table. So the first row here, we call those periods, has 2 elements. So there's a correlation. 2 elements, 2 electrons. If you look at the second row of the periodic table, it has 1, 2, 3, 4, 5, 6, 7, 8 8 elements. Level 2 can hold 8 electrons. Pretty neat, huh? Now, for level 3, you actually have to skip a level on the table because you've got another level of 8 here. But here you are on the next level, when the number changes, number of elements changes, and you can see these are already numbered for you, 1 to 18. So you've got 18 electrons in the third level. The fourth level is there. It's just a little bit trickier to find, and it's right here. If you look at some periodic tables that kind of show you exactly where this comes from, but if you notice, of course, the elements are numerically listed, 37, 38, 39, etc. When I get here to this level, 55, 56, notice that 57 is down here. Same thing for this level, 87, 88, and then 89 is down here. And of course, that's just to keep the periodic table from being roughly twice as wide as it already is. It just makes it convenient to print it, to put it together on a piece of paper. So I'm not going to count them out for you. You can count them out yourself if you don't believe me. But in both of these rows, from 55 through these elements here, then back up 71, starting back with 72 here, all the way to 86, that's where you get the 32 electrons. So you don't have to remember those numbers, you just have to remember how to find those numbers, which is, I think, a little bit easier. So let's look at how you actually draw a Bohr model. The way I do it may be slightly different from a way that maybe you've been taught before if you did this in 7th or 8th grade somewhere back in your past. But the differences are small. It's going to be minor, so don't get too caught up if mine look just a little bit different. Some people do it one way, some people do it a different way, and they're all fine for the most part. I'll talk to you about some things that are non-negotiable. So the first thing we're going to do is just pick an element, and so let's use carbon. I realize that's kind of small, maybe you have trouble seeing it, so we'll draw that block here and see what information we get from that. So we've got the symbol, we have the atomic number of 6, and we have the mass of 12.011. So what I know from the block on the table here is that 6 tells me I have 6 protons. And we said since the atoms are neutral, we also have 6 electrons. I like to include the nucleus, and so I'm going to look at neutrons as well. So carbon happens to have 6 neutrons. And if you remember from the nuclear chemistry unit that we did, the neutrons and protons add up to your atomic number. So it doesn't mean that all of these match. This one just happens to, but it won't always be true. So I'm going to take the mass minus the atomic number, and that is how I get the neutrons. So they may be equal to the others, they may not be. Round to your nearest whole number. This one's pretty close already. So 12 minus 6, and that's where I get that number. So once I have that, I'm just going to put my nucleus together. So hopefully you know that the nucleus has your protons and your neutrons in it. So I'm just going to write 6p and 6n, 6 protons and 6 neutrons in a carbon atom. And I'm going to put a circle around it to represent my first energy level. And so I know that level 1 can hold 2 electrons. So I'm going to draw those in. I'm going to put those together. This is negotiable. Sometimes on that first level, you might see this. You see an electron here and an electron here. Electrons tend to repel each other, and so that's why you might want to put them far apart from each other. But also the electrons exist in something called orbitals that we'll get to later, and so that's why I like to pair them up. There just happens to be one orbital at that level. Again, we'll get to that. So first level is full. So out of those 6 electrons that I have, I've put 2 of them in place. I've got 4 more electrons that need to go into this model. So those have to go in the second level because the first level is filled. Now, this is not negotiable, how you put these electrons in when you've got these higher levels. We put them in at, think about compass points. I always start here at east or 3 o'clock, whatever you want to say, and you put 1 electron in at a time. And so they're at the east, south, west, and north. Some people start at north and work around. That doesn't matter. But the key is you only put 1 in at a time, and you don't pair them up until you have all 4 of those in place. Now for this one, once we get those 4 electrons in place, we're finished. This is the Bohr model for the carbon atom, and we're done with that. Let me show you what I was talking about with something that has a few more electrons. So let's do chlorine. Here's chlorine. Let me change colors. That pink one's about to run low on ink, I think. So in chlorine's block on the periodic table, it has a 17 here, which means it has 17 protons. So it would also have 17 electrons. And its mass is 35.453. Again, just getting the numbers from the table so you can see them a little bit better. So for neutrons, I'm going to take the mass, I'll round that just to 35, subtract the number of protons, and that gives me 18 neutrons. So I'm going to draw a Bohr model from that information. So in my nucleus, 17 protons, 18 neutrons, and the electrons are going in levels around the nucleus. I have 17 electrons to include. When you're doing Bohr models, you don't have to do all of this. It's just this. I'm just trying to help you keep up with what I'm doing and where these numbers are coming from. So just, you don't have to worry about all this. But anyway, 17 electrons. The first two go on the first level. Together or separate, doesn't really matter. So 2 down, 15 electrons to go. The second level can hold 8 of those electrons. I can look there, or I can count there and see that it's 8. 1, 2, 3, 4, 5, 6, 7, and 8. So I'm not to 15 yet. I still have 7 electrons to go. I've put 2 in, then I've put 8 in, 7 left. Sorry. All right, so I need another level. 7 electrons go in this level. 1, 2, 3, 4, 5, 6, and 7. And so now there is a completed Bohr model for chlorine. It's a good idea to take a look at these and practice a little bit. I'm not necessarily going to assign these to you because I'm going to show you some others here in just a minute. I'm going to show you the first 18 finished in another video. But that's how you draw Bohr models. This is not the final model of the atom, but we use this one a lot because it just very clearly shows how these electrons are arranged. So it's something that you need to know and understand what you're looking at when you do see these. So we'll end this video here, and then we'll pick up with another idea about the Bohr model here in just a few minutes.